Multi-master replication is a method of database replication which allows data to be stored by a group of computers, and updated by any member of the group. All members are responsive to client data queries. The multi-master replication system is responsible for propagating the data modifications made by each member to the rest of the group, and resolving any conflicts that might arise between concurrent changes made by different members. Multi-master replication can be contrasted with master-slave replication, in which a single member of the group is designated as the master for a given piece of data and is the only node allowed to modify that data item. Other members wishing to modify the data item must first contact the master node. Allowing only a single master makes it easier to achieve consistency among the members of the group, but is less flexible than multi-master replication. Multi-master replication can also be contrasted with failover clustering, where passive slave servers are replicating the master data in order to prepare for takeover in the event that the master stops functioning. The master is the only server active for client interaction. The primary purposes of multi-master replication are increased availability and faster server response time. Advantages: if one master fails, other masters continue to update the database. Masters can be located in several physical sites, that is distributed across the network. Disadvantages: most multi-master replication systems are only loosely consistent, that is lazy and asynchronous, violating ACID properties. Eager replication systems are complex and increase communication latency. Issues such as conflict resolution can become intractable as the number of nodes involved rises and latency increases. Methods: log-based. A database transaction log is reference to capture changes made to the database. Trigger-based. Triggers at the subscriber capture changes made to the database and submit them to the publisher. With trigger-based transaction capturing, database changes can be distributed either synchronously or asynchronously. Implementations: directory services. Many directory servers based on LDAP implement multi-master replication. Active Directory. One of the more prevalent multi-master replication implementations in directory servers is Microsoft's Active Directory. Within Active Directory, objects that are updated on one domain controller are then replicated to other domain controllers through multi-master replication. It is not required for all domain controllers to replicate with each other domain controller, as this would cause excessive network traffic in large Active Directory deployments. Instead, domain controllers have a complex update pattern that ensures that all servers are updated in a timely fashion without excessive replication traffic. Some Active Directory needs are however better served by flexible single-master operation. Hierarchical framework of objects resources services users provides information on objects, help organize these objects, help perform security functions. CA Directory. CA Directory supports multi-master replication. OpenDS OpenDJ. OpenDS implemented multi-master since version 1.0. The OpenDS OpenDJ multi-master replication is asynchronous. It uses a log with a publish-subscribe mechanism that allows scaling to a large number of nodes. OpenDS OpenDJ replication does conflict resolution at the entry and attribute level. OpenDS OpenDJ replication can be used over a wide area network. OpenLDAP, the widely used open-source LDAP server, implements multi-master replication since its version 2.4.1. Database management systems. Apache CouchDB. Apache CouchDB uses a simple, HTTP-based multi-master replication system built from its use of an append-only data store and use of multiversion concurrency control. Each document contains a rev, so every record stores the evolutionary timeline of all previous revision IDs leading up to its alpha euro, which provides the foundation of CouchDB's MVCC system. Additionally, it keeps a by-sequence index for the entire database. The replication process only copies the last revision of a document, so all previous revisions that were only on the source database are not copied to the destination database. The CouchDB replicator acts as a simple HTTP client acting on both the source and target database. It compares current sequence IDs for the database, calculates revision differences, and makes the necessary changes to the target based on what it found in the history of the source database. Bidirectional replication is the result of merely doing another replication with the source and target values swapped. CloudAnt, a distributed database system, uses largely the same HTTP API as Apache CouchDB, and exposes the same ability to replicate using multiversion concurrency control. CloudAnt databases can replicate between each other, but internally, nodes within CloudAnt clusters use multi-master replication to stay in sync with each other and provide high availability to API consumers. Oracle database clusters implement multi-master replication using one of two methods. Asynchronous multi-master replication commits data changes to a deferred transaction queue which is periodically processed on all databases in the cluster. Synchronous multi-master replication uses Oracle's two-phase commit functionality to ensure that all databases with the cluster have a consistent dataset. Microsoft SQL provides multi-master replication through peer-to-peer replication. It provides a scale-out and high availability solution by maintaining copies of data across multiple nodes. Built on the foundation of transactional replication, peer-to-peer replication propagates transactionally consistent changes in near real time. MySQL, at a basic level, it is possible to achieve a multi-master replication scheme beginning since MySQL version 3.23 with circular replication. Departing from that, MariaDB and MySQL ship with some replication support, each of them with different nuances. In terms of direct support we have, MariaDB natively supports multi-master replication since version 10.0, but conflict resolution is not supported, so each master must contain different databases. On MySQL this is named multi-source currently on Labs release. MySQL Group Replication, a plugin for virtual synchronous multi-master with conflict handling and distributed recovery is currently in development and can be accessed on Labs release. Cluster projects. MySQL cluster supports conflict detection and resolution between multiple masters since version 6.3 for true multi-master capability for the MySQL server. There is also an external project, Galera cluster created by Codership, that provides true multi-master capability, based on a fork of the INNODB storage engine and custom replication plugins. Replication is synchronous, so no conflict is possible. PostgreSQL. The replication documentation for PostgreSQL categorizes the different types of replication available. Various options exist for distributed multi-master, including Bucado, Ruberap and BDR bidirectional replication. BDR is aimed at eventual inclusion in PostgreSQL core and has been benchmarked as demonstrating significantly enhanced performance over earlier options. Various options for synchronous multi-master replication exist. PostgreSQL which is available under the Mozilla Public License, and PostgreSQL which is available under the same license as PostgreSQL itself are examples. Note that the PG Cluster project was abandoned in 2007. PG Cluster proprietary solutions are available from some vendors. Ingres. Within Ingres Replicator, objects that are updated on one Ingres server can then be replicated to other servers whether local or remote through multi-master replication. If one server fails, client connections can be redirected to another server. It is not required for all Ingres servers in an environment to replicate with each other as this could cause excessive network traffic in large implementations. Instead, Ingres Replicator allows the appropriate data to be replicated to the appropriate servers without excessive replication traffic. This means that some servers in the environment can serve as failover candidates while other servers can meet other requirements such as managing a subset of columns or tables for a departmental solution, a subset of rows for a geographical region or one-way replication for a reporting server. In the event of a source, target, or network failure, data integrity is enforced through this two-phase commit protocol by ensuring that either the whole transaction is replicated, or none of it is. In addition, Ingres Replicator can operate over RDBMS unregistered trademark S from multiple vendors to connect them. See also, Flexible Single Master Operation, Active Directory, Distributed Database Management System, DNS Zone Transfer, Optimistic Replication, References. External links, challenges involved in multi-master replication, Active Directory Replication Model, terms and definitions for database replication, Symmetric DS is database-independent, data synchronization software. It uses web and database technologies to replicate tables between relational databases in near real time. The software was designed to scale for a large number of databases, work across low-bandwidth connections, and withstand periods of network outage. It supports MySQL, Oracle, SQL Server, PostgreSQL, DB2, Firebird, Interbase, HSQLDB, H2, Apache Derby, Informix, Greenplum, SQLite, Sybase ASE, and Sybase ASA. Licensed under both open source and commercial licenses. Daffodil Replicator is a Java tool for data synchronization, data migration, and data backup between various database servers. Daffodil Replicator works over standard JDBC driver and supports replication across heterogeneous databases. At present, it supports following databases: Microsoft SQL Server, Oracle, Daffodil Database, DB2, Apache Derby, MySQL, and PostgreSQL. Daffodil Replicator is available in both enterprise and open source versions. Replicator project page, DMOZ Open Directory Project, database replication page.